The evolution of. So, what comes into our mind when we hear the word computer? So, from time to time, there are types of computers that we use over the time. But now, that will be discussed later on by my group mate. So, we're just going to focus on what really is a computer. So, a computer is a programmable electronic device that when we put a raw information, we will be or we will get an outcome in just a matter of seconds. Where does the word computer come from? So, it was derived in a Latin word, computer, computare, that means to calculate, or it's a calculation. So computer is basically a calculator or a calculations of something. And also, a computer is a machine that performs processes, calculations, and many more provided by a software or a hardware. We all know the difference of the two, between the software and the hardware. So, a software is the application within the computer, and the hardware is what you see or it's actually an object that we could use from the computer. And now there are so many benefits of computers. So the first one is it increases your productivity. When we say it increases your productivity, is that you are more likely to work on something, and you'd rather use a computer instead of a cell phone. So basically, if you are to use a cell phone in doing PPTs, analyzing data, it's going to be hard for you to do that because it has a limit. So computer is can give you, or it increases your productivity, because just like what I've said, if you are to do PPTs, analyzing data, it's easy for you to do it because computer, it increases your mood to do such a workloads, school activities. The second one is it connects us to the internet. So we all know that in our generation we are more likely in a technological world. Technology is rapidly increasing. So through the use of computer, we can get an easy access information and also new ideas from the internet. It also connects us with the people in the online world. The third one is storage. So computer has a larger storage than a cell phone, and compared to a cell phone. So computer can hold information, application that no other devices could have. Like, I mean, on a storage, cell phone has like a limit storage that you could use, or you can put limited applications on a smartphone. It has a limit, but in a computer, it also has a limit, but it has a bigger storage than the smartphones. The fourth one, of course, is organized data and information. Computer is a device that can help you to organize your work, like PDFs, files, of course, with no problem. The fifth one is it will definitely improves your abilities. So if you are to do schoolworks or workloads, it will definitely improves your abilities. Like over the time, like you can get new information, new settings on how to do certain things, because we all know that computers are has so many applications or so many techniques on how to do certain things or how to use certain things. So the sixth one is assist the physically challenged. So for instance, you are told to do a presentation but you can't be physically around or can't come to your work. So of course technology introduced computer to ease our problems. So through the use of computers, you can just do presentation at home even if there's a typhoon out there and you can't be at your work. You can just do the presentation and send it to your boss with no problem. The last one is computer keeps us entertained. So computer has it all to keep us entertained. Like there are so many softwares or applications on a computer that we can use to keep us entertained. Like we can watch movies, we can listen to the music, just like Spotify. We can watch like a movie marathon, like Netflix, just like that. So computer has become part of our day-to-day life. When we go to the malls, when we go to school, and when we connect to other people, when we do tradings and all, it's basically part of our life. And there are so many things that we do that is very dependent on computer. And here are some examples. So the first one is the ATM, or the automated teller machine. So we all know that the ATM, or the automated teller machine, is a computerized object or a basic banking function that we do to cash outs, withdraws, and more. The second one is digital currency. So we all know that in our generation nowadays, digital currencies are rapidly increasing. Like in the near future, it will definitely become our alternative money. And also, there are countries that are used to buy things. To buy, for instance, in Dubai, you can buy using a digital currency like the Bitcoin. So digital currency is dependent on computer because it is being computerized and it is digital. From the word digital, it is not physical. So the third one is trading. So trading is dependent on computer because just like if you have in the online market, if you have a online business or stocks, computer is the power, or it can power that can, it is the power of trading workflows. Computer is the power of trading workflows, just like that. So the fourth one is smartphones. So smartphones is being dependent on a computer. Why? Because smartphones is basically somehow a computer because it connects you to the internet. You can get access to so many applications. So it is being dependent to the computer. The last one is the VoIP. VoIP, or also known as the Voice over Internet Protocols, is dependent on the computer because it is basically, it gives you the access to the internet. Like VoIP or the VoIP is, it can convert your voice that can travel, or it can convert your voice into a signal that can travel all around the internet. So again, the internet is there, and it gives you access, easy access to the internet. And if you are using regular phone calls, just like that, as long as it connects you that is considered to be computer, like the voice over internet protocols.
Moving on to the four basic functions of a computer. First, we have input function. The input functions accepts data from input devices and send it to the computer processor. In computing, input refers to any information or data that is sent to a computer for processing. Input devices allow information to be entered into the computer system, either from the user or another computer. The raw information entered into a computer from the input devices. These example of these are the keyboards, mouse, etc. Input functions. In computer programming, an input functions is a way for a program to receive data or information from the outside world. This could be from a user typing on a keyboard, a file being read from a hard drive, or even data coming over a network connection. The input function essentially pauses the program's execution and waits for the user or another source to provide the necessary data. Once the input is received, the program can then process it and continue running. Next, we have the data processing function. Data processing function is the most basic functions of a computer. This function is performed by the Central Processing Unit or CPU, which consists of electronic circuits that can read and execute code instruction to perform a wide range of tasks from performing complex mathematical calculations to sorting the entries in a database. The core is storage, where the prepared data is manipulated and analyzed. Operations such as sorting, summarizing, calculating, and aggregating are performed to extract meaningful insights. Data processing is the method of collection raw data and converting it into meaningful and usable information. Data processing function is the process of converting raw data into useful information. It involves a series of steps. First, we have the data collections, gathering raw data from various sources. Next, we have the data preparation, cleaning and transforming the data into a suitable format for processing. And then third, we have the data input, feeding the prepared data into the computer system. And fourth, we have the data processing, performing operations on the data such as calculations, sorting, and filtering. And fifth, we have the data output, presenting the process information in a usable format such as reports or visualizations. Data storage, storing the process information for future use. Here's an example of data processing. Imagine you have a list of students' names and their scores on a test. You can use a computer to process this data and calculate the average score, identifying the highest and the lowest scores, and generate a report summarizing the results. Third, we have the output functions. Output functions is the process of producing the useful information for user after processing input data. The results of data processing are presented in a comprehensible format, such as reports, charts, graphs, or other visual representations. Output process in computer science refers to an output functions refers to a function that is responsible for producing or displaying the results of a program or process. It takes the process data and presents it in a human readable or usable format. The primary purpose of an output function is to communicate the results of a program or process to the user or another system. This can involve displaying information on a screen, printing it on a paper, sending it over a network, or storing it in a file. Output functions can produce various types of output, including text, numbers, images, audio, and video. The specific type of output depends on the nature of the program or process and the intended use of the results. Output functions often interact with output devices such as monitors, printers, speakers, and storage devices to present the results. Lastly, we have the data storage function, the final stage. The final stage involves storing the processed data for future reference and analysis. This ensures the longevity and accessibility of valuable information. One of the most useful functions of a computer is data storage. Data storage function is the process of recording and preserving data on a storage medium so that it can be accessed and used later. This is a fundamental function in computing, as data is essential for almost all applications and operations. So, we have key functions of data storage. First, it ensures that data remains intact and accessible over time, even in the face of system failure or other disruptions. Providing quick and reliable access to stored data, allowing users and applications to retrieve and use the information as needed. Second, we have data management, facilitating the organization, categorization, and management of data, making it easier to find and use. Third, we have the data security, protecting data from unauthorized access, modification, or deletion, ensuring its confidentiality and integrity. And fifth, we have the data sharing, enabling the sharing of data between different users, applications, or systems, promoting collaborations and data utilization. To store data and information, a computer uses two types of storage components. First, we have the temporary storage. Temporary storage in a computer refers to the memory that a computer uses to hold data and instructions that is actively working on. This type of memory is called random access memory or RAM. Random access memory, this is the most common form of temporary storage. Think of it like your desk. While you're working on a project, you keep all the important documents and tools you need within easy reach. RAM works similarly, holding the data that your computer's processor needs to access quickly. RAM is volatile, meaning that it loses its contents when the computer is turned off. This is why it's temporary. Once you shut down your computer, the information stored in RAM is erased. Temporary storage in a computer, most commonly known as RAM, serves a crucial role in how your computer functions. Here's a breakdown of its purpose. First, the speed and efficiency. RAM provides incredibly fast access to data, much faster than permanent storage devices like hard disk or SSDs. This speed is essential for the processor to quickly retrieve and process information. Second, we have the active data. RAM holds the data and instructions that the computer is actively using right now. This includes the operating system, applications you have open, and any files you're working on. Third, we have the enabling multitasking. Juggling multiple tasks, RAM allows your computer to handle multiple tasks simultaneously. Each program you open and file you use is loaded into RAM, allowing you to switch between them seamlessly. And on the other hand, we have the permanent storage. Permanent storage, also known as persistent storage, refers to any data storage device that retains data even after the power to the device is turned off. This is in contrast to temporary storage, like RAM, which loses its data when the power is off. Here are some key characteristics of permanent storage. First, it is non-volatile. Data is retained even when the device is powered off. Second, long-term storage, designed for sorting data for extended periods. Here are some common examples of permanent storage devices. First, we have hard disk drives or HDDs, traditional storage devices that use spinning platters to store data. Next, we have solid state drivers or SSDs, faster and more durable, using flash memory store data. Optical discs, CDs, DVDs, and Blu-ray discs that store data using laser. Next, we have USB flash drivers, portable storage devices that use flash memory. And lastly, we have memory cards used in cameras, smartphones, and other devices. So, permanent storage is essential for storing operating systems and applications. The software that runs your computer is stored on permanent storage, saving user data. Documents, photos, videos, and other files are stored on permanent storage. Archiving data. The important data can be stored on permanent storage for long-term preservation. Moving on to the characteristics of a computer. First, we have speed. It is one of the most fundamental and noticeable characteristics of computers. Here's a breakdown of how speed defines a computer. First, the processing power. Computers can perform complex mathematical operations at incredible speeds, far exceeding human capabilities. This allows them to handle massive data sets, run simulations, and perform intricate calculations in a fraction of the time it would take us. Second, instruction execution. At its core, a computer's speed is about how quickly it can execute instructions. These instructions can be anything from moving data around to performing logical comparisons. The faster the execution, the faster the computer. Data handling. Computers can retrieve data from memory and storage devices at lightning speed. This is crucial for quickly loading programs, opening files, and accessing information from the internet. And of course, responsiveness. A fast computer responds quickly to user input, such as mouse clicks, keyboard process, and touchscreen's gesture. This makes for a smooth and enjoyable user experience. Of course, task completion. Ultimately, a computer's speed translates to how quickly it can complete tasks. This can be anything from rendering a video to processing a large batch of transactions. Second, we have accuracy. Accuracy is a fundamental characteristic of computers. It refers to the ability of a computer to perform a calculations and operations without errors. High degree of precision. Computers are designed to perform calculations with a very high level of precision. This means they can handle complex mathematical problems and produce results with many decimal places without rounding errors. The chance of a computer making an error in its calculation is extremely low. Most errors that occur in computing are due to human mistakes, such as incorrect data entry or flawed programming, rather than the computer itself's malfunctioning. Third, we have diligence. Diligence in the context of a computer refers to its ability to perform repetitive tasks with consistent accuracy and without getting tired or bored. Unlike humans, computers don't experience fatigue, lack of concentration, or boredom. This allows them to perform tasks for extended periods. Computer can work tirelessly for hours, days, or even weeks without needing a break as long as they have a power source. Fourth, we have versatility. Versatility in the context of computers refers to their ability to perform a wide range of tasks, unlike specialized machines designed for a single purpose. Computers can be adapted and programmed to handle diverse operations. We have key aspects of versatility. First, multitasking. Computers can execute multiple tasks concurrently, switching between them seamlessly. For example, you can write a document, browse the web, and listen to music simultaneously. Adaptability. Computers can be connected to various peripherals and devices, extending their capabilities. This includes printers, scanners, cameras, and even other computers, enabling them to interact with and control the external world. Examples of versatility in action: word processing, writing documents, creating reports, and editing texts; graphic design, creating visual content, editing images, and designing layouts; data analysis, of course, processing large data sets, performing statistical analysis, and generating reports; communication as well, sending emails, videos, conferencing, and accessing social media; and of course, entertainment, playing games, streaming movies, and listening to music. Next, we have power of remembering. This is the fifth. The power of remembering is a key characteristic of computers, and it refers to their ability to store and retrieve vast amounts of information. Here's a breakdown of what that means. Storage capacity. Computers can hold incredible amounts of data, far exceeding human memory. This include text, images, videos, programs, and more. Computers remember information perfectly without the distortions or fading that can occur with human memory. Data can be stored for years or even decades as long as the storage device is functional. Computers can access and retrieve stored information very quickly. And six, we have the characteristics of a computer. It has no IQ, does not apply to computers. Here's why. Computers lack consciousness and the subjective experiences. IQ tests are designed to evaluate human intelligence, which is deeply intertwined with consciousness, self-awareness, and subjective experiences. Computers, despite their advanced processing power, do not possess these qualities. Computers operate based on program instructions. Computers function by executing pre-programmed instructions. They cannot think or reason in the same way humans do. Their actions are determined by algorithms and code, not by independent thought or understanding. While computers can perform complex tasks and even mimic certain aspects of human intelligence through artificial intelligence or AI, they do not have an IQ. The term IQ is exclusively applicable to human beings. And seventh, we have no feelings. Computers are machines. They can process information and perform tasks with incredible speed and accuracy, but they lack the complex biological and emotional makeup that allows humans and other animals to experience feelings. Here's why. Because They're no biological. Feelings are deeply connected to our biology, involving intricate networks of neurons, hormones, and neurotransmitters in the brain. Computers, on the other hand, are built with electronic components, not biological ones. They don't have the same brain structures or chemical processes that gives a rise to feelings. They are lack of consciousness. Feelings are often tied to consciousness, our awareness of ourselves and the world around us. While computers can stimulate some aspect of human intelligence, they don't possess the same kind of subjective awareness that allows us to experience emotions. Computers operate based on algorithms and instructions that are programmed into them. They can respond to different outputs in predictable ways, but their responses are determined by their programming, not by genuine emotions. And six or eight, I should say, is storage. Storage is a fundamental characteristics of a computer that allows it to retain data and programs for future use. It's like the computer's long-term memory, holding everything from your operating system and applications to your personal files and photos. Unlike RAM or random access memory, which loses its contents when the computer is turned off, storage devices retain data even when the power is off. This is crucial for saving your work, keeping your files organized, and ensuring that your computer can start up again with all its software intact. Computers can store massive amounts of information thanks to storage devices with ever increasing capacities. This allows you to keep a vast library of files, programs, and media on your computer.
Good morning everyone. Today I will be discussing the history of computer. We start as early as 4000 BC with the Chinese abacus. How is this related to computing, you ask? The abacus was one of the first machines humans had ever created to be used for counting and calculating. It was a wooden rock which has metal rods with weights mounted on them. The abacus operator moves the bits according to some rules in performing arithmetic calculations. In 1614, John Napier invented logarithms to simplify complex calculation. Among its methods to speed up arithmetic was Napier-Bones. It was manually operated calculating device where he used 9 different ivory strips or bones marked with numbers to multiply and divide. It was also the first machine to use decimal point. Between 1642 and 1644, the first mechanical and automatic calculator was invented by a French mathematician philosopher Blaise Pascal. This is known as the Pascaline. Could only do addition and subtraction with numbers being entered by manipulating its dials. A series of windows is given at the top of the wheels to read the totals. A German mathematician philosopher Gottfried Wilhelm improved Pascal's invention by developing his own machine in 1673. It was a digital mechanical calculator which was called step reckoner. The calculator can add, subtract, and multiply and also divide. Wheels are placed at the right angles which could be displaced by a special stepping mechanism. In the early 1820s, the father of modern computer, Charles Babbage, originated the concept of programmable computer. He conceptualized and invented the first mechanical computer with this revolutionary difference engine. It was a mechanical computer that could perform simple calculations and a steam-driven calculating machine designed to solve tables of numbers like logarithm tables. However, in 1830, Babbage realized that a much more general design was possible, the analytical engine. It was a mechanical computer that used punch cards as input. It was capable of solving any mathematical problem and storing information as a permanent memory. The next major changes in the history of computers began in 1937. Howard Aiken planned to develop a machine that could perform calculations involving large numbers. In 1944, Mark I computer was built as a partnership between IBM and Harvard. It was also the first large-scale automatic digital computer in the United States. Howard Aiken was colleagues at Harvard and collaboration with IBM began working on the Harvard Mark I calculating machine, a programmable calculator inspired by Babbage analytical engine. This machine was composed of nearly 1 million parts and weighed nearly 5 tons. The Mark I had 60 sets of 24 switched for manual data entry, could store 72 numbers and each 23 decimal digits long. It could do 3 additions or subtractions in a second. A multiplication took 6 seconds and a division took 15.3 seconds. And a logarithm or trig function took about 1 minute. As a funny side note, one of the primary programmers of the Mark I, Grace Hopper, discovered the first computer bug, a dead moth blocking one of the reading holes of the machine. Hopper is also credited with the word debugging.
Good morning, everyone. Today I will be discussing the different generation of computers. Our journey through the 5 generation of computers starts in 1940 with vacuum tube circuitry and goes to the present day and beyond with artificial intelligence systems and devices. The first computer system uses vacuum tubes for circuitry and magnetic drums for main memory. And they were often enormous, taking up the entire room. These computers were very expensive to operate. And in addition, using a great deal of electricity, the first computer generated a lot of heat, which was often cause of malfunctions. First generation of computers relied on machine-level language, the lowest level programming language understood by the computers, to perform operation. The input was based on punch cards, paper tick, and the output was displayed on printouts. The Univac and the ENIAC computers became the examples of the first generation computer technology. The world would see the transistor replace the vacuum tubes in the second generation of computers. The transistor was invented at Bell Labs in 1947, but did not see the widespread use in computers until the late 1950s. The second generation computer still relied on punch cards for input and printouts for output. Second generation computers moved from strictly binary language to symbolic or assembly language, which allowed programmers to specify instruction in words. The development of the integrated circuit was the hallmark of the third generation of computers. Transistors were miniaturized and placed on silicon chips called semiconductors, which drastically increased the speed and efficiency of computers. Instead of punch cards and printouts, users would interact with the third generation computer through keyboards, monitors, and interface with an operating system, which allowed the device to run many different applications at one time, with another central program that monitored the memory.
Good day everyone, I'm Christine Joy Collado and I will continue the report of Mr. Lab. So the fourth generation of computers, spanning from 1971 to 1980, marked a significant advancement in computing technology through the introduction of very large-scale integrated or VLSI circuits, a chip containing millions of transistors and other circuit elements. These chips made this generation computer more compact, powerful, fast, and affordable. Example of popular fourth generation computers: VEC-10, Star 1000, PDP-11, Cry-1, Cry-XMD. In fifth generation computers, on 1980 until today, the VLSI technology was replaced with ULSI, or Ultra Large Scale Integration. It made possible the production of microprocessor chips with 10 million electronic components. These generation computers use parallel processing hardware and AI, or artificial intelligence software. These programming languages used in this generation were C, C++, Java, .NET, and etc. Examples of fifth generation computers: desktop, laptop, notebook, Ultrabook, and Chromebook. The classification of computers into categories such as purpose, data handling, and size. Each classification serves a specific purpose into the realm of computing, allowing users to select the appropriate type of computer based on their needs. The classification of purpose. First is the general purpose computers. It is designed to handle multiple tasks with the ability to store and run various programs. However, they may not be highly efficient for specialized tasks. The second one is the specific purpose computers. It is built for a specific function such as controlling traffic lights, medical imaging, or military application with optimized hardware and software. So let's proceed to next classification, which is the data handling. So the first one is the analog computers. Analog computers use continuous signal like electrical voltage or mechanical movement to stimulate real-world scenarios used in scientific and engineering applications. The next one is the digital computers. So digital computers operate using discrete numerical data or binary commonly used in everyday computing devices. And the last one is the hybrid computers. So hybrid computers combine the features of analog and digital computers, often used in medical application and scientific stimulations. So the last classification was classification on the basis of size. So the first one was supercomputers. Supercomputers, the fastest and most powerful computer used for scientific research, weather forecasting, nuclear simulations, and large-scale computations. Next one is mainframe computers. Mainframe computers, large and expensive system capable of supporting hundreds or thousands of users simultaneously, commonly used by banks, airlines, and government institutions. Next one is mini computers. Mini computers, mid-size, multi-user computers used for business and scientific applications. They are more powerful than microcomputers but less than mainframes supporting 4 to 200 users simultaneously. The next one is microcomputers or personal computers. These are the most commonly used computers today, designed for individual users. They include desktop computer. Desktop computer is stationary PC suitable for office or home use. Next one is laptop computer. Laptop computer, a portable version of a desktop with a built-in screen and keyboard. And the last one is PalmTop or PDAS. PalmTop, handheld devices for basic computing used for schedules, notes, and contacts. Last one is workstations. Workstations, a terminal or desktop computer in a network. In this context, workstation is just a generic term for a user's machine or client machine in contrast to a server or mainframe.